Всем привет, дорогие соотечественники. Hello guys, my name is Mr. Bektur.
My name is Bektur. Hello, everyone.
And here today I have an amazing, awesome, bazarcı guest. Mr. Bektur, he's our physics teacher. Mr. Bektur, be welcome here.
Thank you. So my name is Bektur. As Mr. Bektur said, I'm a physics teacher in Kelechek, MIT. It's a third year here. What can I tell about myself? I like science stuff, as you could understand. I like math. I like computer games. I like listening music, watching sci-fi movies. I don't cook much, but I like a very tasty food.
You like to eat, eh?
Yeah, sure. And
Okay.
my favorite food is mante.
Mante.
It's always been, yeah.
Mr. Bektur, we said here you are a physics teacher. When did you take your decision, in a briefly way, to tell us?
As far as I remember, I always liked mathematics, you know, from the first grade, even before the school. Or my older brother, when he studied mathematics, it was very amazing and interesting for me. And as well, my father is an engineer, electrical engineer, and it was always interesting for me as a kid to look how he repairs, fixes some electrical devices. And it was amazing for me how metals, like wires, make some interesting things like watching movie or television set or phones, and I always tried to fix them with my father, and it was always interesting for me how things work. And getting to school, I started mathematics, and it was very interesting till the 7th or 8th grade when physics subject started. And our teacher said the first lesson about physics was the physics means nature, and not only nature but nature of things, how everything works in our universe, in our world. And it was very interesting for me. As well, you can use the mathematics which you like mostly in this subject, and that's why I chose physics. And I went to the Olympiads in physics, and it was getting more and more interesting. And the more it gets complex, the more interesting was it for me.
And guys, today we're gonna be talking here about some principles of physics and how it can be applied in our daily life, you know? So, but of course, don't forget to give your like and subscribe, okay? So, let's start with something very basic. Running. Mr. Bektur, a question. I always notice, for example, that when we start running, we kind of lean forward. But when we start to stop running, for example, we lean back. For example, can you tell us what are the physics behind that?
Oh yeah.
In English or in Russian, as you want.
Okay, let me try. As you said, it's basic, but usually in physics, it's very interesting that what seems very basic usually are more complex than what seems complex, you know? And let me try to make it simple. As we run, we move forward, or when we stop, we slow down. So it's about forces. And as we know, there are many types of forces, like, for example, the upthrust force, the reaction force, the friction force, and all of them are involved in such activities, especially the reaction force and the friction force, which we usually ignore in our lessons, you know. But without them, we won't be able to walk even. So when we walk, if you look closer or just take a wider look, so you will see how we lean forward to make an angle between the normal force or ground and such the component, the horizontal component of the force makes you go forward. And it is possible because there is a friction between your feet and the ground. So if it weren't, you would slip down and you wouldn't be able to walk even. So it's the normal forces horizontal part, which is equal to the friction force by the third Newton's law. So what that makes you go forward. So when you lean forward, you can think about it like this. So when you lean forward, as if you are falling down, and you every time stepping, you're catching yourself. So if you wouldn't lean, the normal force would always act vertically upwards, and you would stay on the same place, and that makes you go forward. And the more you lean, the faster you have to move. So that's why when you're running, you're almost like 70 degrees, I think, approximately, you know. So that's I think the basic part of the physics of walking or running.
Guys, like something that you do every day, walking. Question, you want to add something else?
I want to stop on one point. As I said, it's a very complex thing. I think many of us noticed in videos how people started to make robots, and it's very difficult to make them walk like a normal human, because it's very difficult, complex physics. We do think that it's very simple thing, but if you remember how you started walking as a kid, it took a couple of years maybe. So it's our brain makes it automatically, but in reality it's a very complex thing.
Next question, Mr. Bektur. Look, about doors, okay, and torque. Look, something that we do every day, we open doors. So now, a very simple question, maybe you tried at least once in your life. Now, Mr. Bektur, why is it so much easier to open a door from the handle than if we tried near the hinge? What is the main difference? What is the physics behind it?
So there's a thing that's called torque in physics, but in Latin you can call it moment, moment of force. So it's not only about how hard you push or pull. Other things very important is how you act this force on something. So if you put it, as you said, on the door handle, it's another effect. And if you put it the same force on the hinge, or it acts as a pivot or fulcrum, it has another effect. So here comes the concept of torque. It means how you act your force on the same thing with the same amount, but gives another effect. So torque means when you multiply force by distance to the fulcrum. So the more the fulcrum, the more the torque you have. So as you know, cars also have parameters like torque, like turning effective force. So the more the turning effect, the more powerful it seems. So it's easier to push the door to open it from the hinge or from the handle because it's more distance from the hinge. The nearer to the hinge, the more torque you should, the more force you have to act to apply the same torque. Also, you should think of it's the angle of appliance also. So if you push the door from not the handle side, but as if you are pushing the door to the hinge, there will be no effect because the angle of appliance is also a very important part. So you have to put it perpendicular to the door, that it will be the maximum effect of the force.
So now let's go, guys, to the question number 3, and it's related to something that you use every day, and also I use every day. Mr. Bektur use every day. What is it? It's phones, okay? Phones. Mr. Bektur, why our phones they get hot, especially when we are playing video games or when we are watching movies or something like this?
So as you know, the phones and other devices are electronic devices or electrical devices. We call them electronic because we use electronics there, but still there is electricity there. So as you know, one of the effects of electricity is to heat up. So when electrons pass through the wire, they hit the other atoms and it makes them move faster, and it's a heat. So when you use the phone, or the more you use, the more computations make more electricity go through wires, and there's a heat in these devices come up, so it gets hotter and hotter.
Okay, so that's the explanation.
Yeah.
Can it be dangerous?
So if you use it more than recommended, yeah, the heat can make wires melt, and your device will no longer work properly.
And also some people. And also, I'm gonna ask again the question: is it dangerous? I'm gonna cut. Is it dangerous? Is it dangerous? And Mr. Bektur, now another question. So I've heard that it is not recommended to put your phone on your bed when you are sleeping and put them to charge, because maybe they can, heat up and maybe, I don't know, start a fire or something like this.
Yeah.
Is it true?
Yeah, that's especially true when we use lithium-ion batteries, because they are very very dangerous in a manner they can get really fast fire, so it can get flamey, and usually when you sleep on mattress or mats, they can catch fire quickly. So it's pretty dangerous to use them in charge or sleep while it's in the charge.
Now, something else that is very common, interesting, and also beautiful, let's put that way, is like usually after rain we can see the rainbow, right? And it's something beautiful, awesome, but also there's a very interesting but not so simple physics concept behind it, right?
Yeah.
Mr. Bektur, could you explain us, for example, what is like the magic or the physics behind the rainbow? How does it work?
Oh yeah, the thing, the rainbow is a colorful thing, which is created from just a white light. Is very interesting, and it was very interesting for humankind for all history, until Newton came in and he tried to explain it using his prism. He showed that the white light, as we used to see from sun, can be broke down into 7 colors using prism. So it's because of the light's wave nature, and there's a phenomenon that's called refraction. So when light waves go through one medium to another medium, they change their speed. So different colors of the light has different changes in speed, so they start to bend. So every color bends in different angle. So from the far distance, you could see how they they are divided into distinct colors. But it's just a prism, you know, that light can be divided into 7 colors. But behind the rainbow physics, it's pretty complex, that every drop is refracting raindrop is refracting the light. At the same time, it is reflected inside the raindrop, and it has to be a distinct angle between you, sun, and the water, and the shape of the water, that you could see such a beautiful rainbow, you know, just not just divided colors, but a bow, like arc. So it's pretty difficult to explain just in words, so you have to draw geometrical like lines, calculate the angles, and they are exact angles. So it's very interesting. If you want to discover it further, it will be very interesting for you, I think.
Mr. Bektur, why do our voices echo in empty rooms but not in furnished ones?
No, if you want to understand it in a simple way, it's about absorption and reflection of sound waves from the, let's say, screen or a wall. So some materials can absorb sound waves, like for example sponge-like things, or maybe clothes, maybe fur. That's why some microphones have fur around it when you're
Or in
talking
Russian would
windy.
be
Mech. Mech, пушистый.
From the cats.
yeah, like cats. Or but at the same time, like metals or flat things or very solid things, they don't absorb but rather reflect the sound wave when something hits on it, like a ball hits on it, and it bounces back. The same acts as how particles of air hit the wall and bounces back. So it reflects the sound, so you can hear your voice again, so it's called echo. And that's the physics behind it.
Mr. Bektur, in order to finish here, what would be your advice to the students who are struggling with physics, or maybe they think, I think physics, math, physics especially, is not for me?
I think physics is just a way of explanation or description of the nature around us, which surrounds us everywhere and every time. So I think it has to be interesting for everyone to know how everything works, at least to get use of it, or to be able to protect from its harmful parts. So when you study physics, think of it like as you are studying just life, and how to get the best of it. And math just helps you to make conclusions, to take some facts and make some relationships and make laws or something else to understand it better. So physics as a subject and the math as a tool for it helps you to understand it in a better way, so that you can get the best of it. So I would recommend it to learn it as an interesting thing to get the best of life.
Okay. Mr. Bektur, thank you very much.
Thank you.
It was a pleasure.
It was very interesting, but a short time, but
it was
it's
great.
just the beginning, I think.
Mr. Bektur, yes, of course. Mr. Bektur, he'll be back here soon. We're gonna let you know. So guys, don't forget, give your like, subscribe. Any questions in English and Russian, write in our comments, and Mr. Bектuru will answer later, okay?
Yeah, I'll do my best.
See you Bye-bye.
Bye.
Пока-пока.